The calculated precision of this Han conquest is simply astounding. Shui Qingyao's deft diplomacy turns fear into collaboration, while Shui Tu's military tactics are a chilling spectacle of ruthless efficiency. That encircling hunt, funneling the Shin forces into capture, prioritizing future labor over immediate annihilation, is pure strategic genius. The visceral fear inflicted by the Han artillery feels incredibly real. What truly captivates me is the sheer foresight. Even as the battle concludes, plans for public trials, prisoner reform, and long-term governance are already unfolding, alongside the chief's ambitious industrial projects far from the front. It's this blend of overwhelming might and meticulous, almost cold-blooded nation-building that defines their campaign. With the Eastern Front collapsing so decisively, and the Han machine already shifting focus to administration and further expansion, can the remaining Shin territories even hope to mount a meaningful resistance? Or is their assimilation already a foregone conclusion? To put it nicely, this industrial county was simple. To put it bluntly, it was a sprawling complex of bare-bones buildings. You had truly wanted to build a super factory as large as the county seat in one go. But alas, for now, this industrial county was merely a rudimentary prototype. A few large warehouse-like structures stood there, serving as the face of the industrial county. To be frank, it was all factory workshops, surrounded by a few scattered small single-story houses where the workers and researchers were holed up. This industrial county could be called a real oddity in our Han tribe. Oh no, the most distinctive county. Back when you decisively slapped your thigh and declared this place the heart of industry, the place from which future trains would chug, city walls became a non-starter. They'd just be in the way. This area was never planned for habitation. It was entirely an industrial development zone, a cluster of factories where unauthorized personnel were not permitted. Many of the personal guards were visiting this new industrial city for the first time, Ku Bing among them, his eyes wide as saucers. He had seen steam engines in Hanyang City that could move on their own, belching smoke, and now he realized this was where it all originated. At that thought, his curiosity flared up as if he'd been given a shot of adrenaline, and he was eager to explore everything in the industrial county. Once the horses were tethered, you led your personal guard straight to the Power Research Institute. It had that familiar factory style. Inside, things were hong long long. The steam engines were roaring away merrily. From the roof, enormous brick chimneys spewed black smoke into the sky with such abandon that the swirling snowflakes were nearly dyed gray. Only 2 people were waiting at the entrance. There was none of the grand reception that usually accompanied a leader's inspection. Elsewhere, a whole crowd would have swarmed out to greet you. But at the Research Institute, all red tape had to give way to work. After all, you couldn't just show up and have all the machines grind to a halt, could you? How much of the coal boss's precious fuel would that waste? Chief, Mu Xing, the head of the Research Institute, hurried forward, cupping his hands in greeting. You nodded and got straight to the point. How have things been lately? Everything running smoothly? The personal guards automatically dispersed to stand guard at various entrances and junctions, leaving only Ku Bing and another guard captain by your side as you plunged into the workshop. Mu Xing, a troubled look on his face, reported as he walked beside you. Chief, our progress has stalled, mainly due to a shortage of manpower. Those young students you approved are all assisting the researchers now, learning theory while working, like ducks being force-fed. As for production and manufacturing, he continued, our R&D team is already stretched incredibly thin. How could we find the time to personally go down and tighten screws? We've had to draw skilled blacksmiths and carpenters from Weishan Prefecture and other prefectures to undergo training, learn to operate steam-powered lathes and other machinery, and help us process parts. From what I can see, these blacksmiths and carpenters pick up mechanics incredibly fast. After all, they were already adept at tinkering with wooden machinery. You silently gave a thumbs up in your mind. Master carpenters, true legends. Any true craftsman capable of independent work is an educated man in his own right. Of course, this didn't include the modern types who only knew how to press buttons on power tools. They were mere woodworkers, a whole generation away from being true artisans. How is the R&D and manufacturing of steam engines coming along? You pressed. Musing quickly replied, Chief, we are currently focused on modifying the Iron Horse Mark I so it can be fitted onto various lathes to provide horsepower. Additionally, there's the upgraded version of the Iron Ox Mark I and the R&D for the Iron Ox Mark II. We've already designed an Iron Ox Mark II steam engine, which is essentially a plus version of the Iron Ox Mark I. The main goal was to increase its ox power, so we used larger diameter, long-stroke cylinders and a bigger boiler. We've already built a few prototypes. We're thinking of using this Iron Ox Mark II to power cranes, large stamping presses, plate rolling mills, and steel rolling mills. Oh, and those steel rails you mentioned. We'll probably need this powerhouse to drive the machinery for rolling them. The group chatted as they walked, and before they knew it, they had wandered into the Institute's design department. Inside, researchers and young students were all buried in hard work. As you looked around, your gaze was captivated by a set of blueprints on one team's table. You casually picked them up. What's this contraption? When the team leader saw it was you, his face immediately broke into a wide smile. After all, you were the founding master of their field. He first bowed formally before saying, Chief, this is our newly designed steam-powered blowing equipment. We plan to use the Iron Horse Mark I to drive bellows to create a draft for the blast furnace. You nodded, your expression unruffled, but a few words escaped your lips. Scrap it. The design is a complete failure. Chief, this... They had toiled for over half a month, recalculated the blueprints countless times, and even built a scale wooden model for testing. Now your esteemed self had shot it down with a single sentence, calling it a complete failure. Who could bear that? You, however, remained perfectly calm and began an impromptu lesson. I'm telling you, your thinking has gone down a dead end. The successful operation of the steam engine opened a new world for you, making you think any machine can be powered by a steam engine. That idea itself isn't wrong, but your way of using the steam engine is completely and utterly wrong. Take this blowing equipment you mentioned, you said, pointing to the blueprints, using a steam engine to drive bellows with a reciprocating push-pull action to supply air to the furnace. How low do you think the efficiency would be? How high would the energy consumption be? So much of the output power is wasted in the mechanical travel. A machine isn't better for being more complex. High efficiency, low energy consumption, and ease of maintenance are what make it best. If you want to deliver air quickly, theoretically, the bellows diameter needs to be large enough, and the piston's reciprocating speed needs to be faster. But that's too complicated. It would be better to directly use a steam engine to drive a fan for air supply. You know windmills, right? They use the rotation of blades to generate wind. All of you, remember this well. Rotary machines are far superior to reciprocating ones in terms of power delivery because they can transmit torque directly to the machinery without needing to convert it into reciprocating motion. The moment the team leader heard you mention windmill, his eyes lit up instantly. He was familiar with windmills. Such large machines were common throughout the Han tribe. But he had always thought windmills were for harnessing the wind, never imagining they could actively generate it. This new concept you proposed immediately piqued his interest. Thank you, Chief, for your enlightening guidance. We will revise the plan as soon as possible, the team leader said, bowing respectfully at once. Good. Your intentions are good, but you need to think more creatively. Don't let your thinking be constrained by existing things. I very much look forward to you imagining things even I can't come up with. Also, regarding fans, you paused. I'll give you a general idea, and then you can research and experiment yourselves. If this thing is done well, it will be very useful. Study it carefully. I have great plans for it in the future. As you spoke, you picked up a pencil, compass, and other items from the table and, with a few quick strokes on the back of their blueprint, drew a circle. Inside, you casually sketched a 4-bladed fan, then versions with 3, 2, and 5 blades. You also added a simple side view, marking the angle of the fan blades. Forge the blades from metal, then drive them to rotate, and they'll generate airflow in one direction. Forward, it blows air. Backward, it sucks air. This thing has great development potential. If you master it, I guarantee it will benefit you for a lifetime. Get to it. You patted the shoulders of a few of the young men and continued walking. Guru Bing, listening beside you, was stunned. He quickly took a few more glances at the strange symbols you had just drawn, silently memorized their appearance, and then hurried to catch up. Mu Xing still stuck close by, ready to continue introducing the Institute's situation at any moment. Sure enough, just after the discussion about the blower, you asked another question. How is the steam locomotive project progressing? Mu Xing immediately replied, reporting to Chief, we've nearly completed the theoretical design for the steam locomotive. Following the ideas and models you provided, we've finished the initial blueprints. However, we've been too busy lately and lack the manpower to start experiments. Everyone's currently focused on the steam power conversion of the Mint. Also, we currently lack the capability to process many of the locomotive components, so we can only consider trial producing a prototype vehicle after our machining capabilities improve. You knew, of course, that steam locomotives weren't so easily made. And given the current situation, it indeed had to be queued for later. Manpower was short, yet projects had to be prioritized. Something like a steam locomotive, which wasn't an urgent need, could wait a bit. You didn't intend to blame them, instead you hoped to offer some assistance. So you asked, do you have any design ideas or practical difficulties you've encountered? Tell me about them. Perhaps I can help you solve them. Hearing this, Mu Xing's eyes practically lit up with an eager gleam. It was common knowledge among everyone that the chief was a master in the field of mechanics, their founding patriarch. Opportunities to consult the chief were rare indeed. No sooner had your words faded than Mu Xing spilled everything out at once, like beans pouring from a bamboo tube. Chief, we've mentally walked through the steam locomotive construction process, and we've encountered some machining difficulties in our current steam engine production. What the Institute urgently needs right now is a more convenient drilling device. Ideally multi-angle, lightweight, perhaps even a handheld metal drilling tool. This would be a great help for manufacturing large boilers. Drilling? How so? What are you using now? You asked, somewhat curious. Chief, please come this way. Mu Xing led you to a rather large piece of machinery. Take a look, Chief, he said, pointing to the big, clunky, and crude machine. This is the large steam-powered drill press we currently use. It employs an iron horse Mark I steam engine to drive the drill bit, boring holes in steel plates. Then we use a plate rolling machine to form them into cylinders and fabricate the steam engine boilers using welding and riveting. But this drill press is adequate for producing small boilers, Mu Xing said with a troubled expression. When it comes to producing the kind of super-large boilers needed for locomotives, this drill press really struggles. Moreover, our desire to build even larger steam engines is currently limited by our drilling technology. We just can't make them. Let me think. You nodded, stroking your chin in understanding. Drilling holes in steel was indeed a problem, especially since those big, clunky pieces of equipment couldn't always be processed on a drill press or lathe. A handheld drilling device was certainly something the Han tribe urgently needed. Unfortunately, in this primitive society, light bulbs weren't even a glimmer on the horizon, so there were no generators, let alone electric motors. Thus, a handheld electric drill was out of the question. Since there were no electric drills, what could be used for handheld drilling? Ruling out electrical equipment, your mind turned, and a term popped out. Pneumatic drill, also known as an impact wrench. An impact wrench was a handheld rotary tool powered by high-pressure air. Attach a socket, and it could tighten or loosen bolts. This tool was very common in auto repair. Almost all tire lug nuts were removed using one. The sound it made was very distinctive. Rat-tat-tat-tat-tat, whoosh. And quite mesmerizing. The same device, if you removed the socket and replaced it with a drill bit, hey presto, became a handheld pneumatic drill. This device actually posed no major technical hurdles. It could be broken down into three parts: the tool itself, an air compressor to provide power, and a hose to transmit the high-pressure air. The tool itself wasn't anything high-tech or sophisticated. It just contained small parts like a turbine and a ratchet, which wasn't an issue. The high-pressure air hose was also manageable. The Han tribe now had a stable supply of rubber, so manufacturing some rubber air hoses wasn't difficult. The issue of the rubber tube withstanding air pressure was trickier, as the Han tribe couldn't yet produce soft, pliable plasticized rubber, a materials problem that couldn't be solved for now. However, other methods could substitute, such as adding a non-elastic canvas sleeve over the rubber tube, giving it a soft armor jacket to act as flexible protection, limiting the rubber tube's expansion. Thus, the air hose problem could also be solved. Finally, there was the most important component: the air compressor. The moment you thought of an air compressor, an idea flashed in your mind. Holy cow, this thing seemed to have incredibly broad applications, far beyond just powering pneumatic tools. If the Han tribe had this, things like spray painting wouldn't be a dream, and processes like film blowing for rubber products and glass blowing for glassware all required air compressors. How had you not thought of this before? At this thought, you were overjoyed. With a grand wave of your hand, you spoke to Mu Xing. High-pressure gas for tools? Mu Xing's jaw nearly hit the floor. Your imagination was wider than the sky. He muttered to himself, could it be shrinking a cylinder and piston, stuffing them into a tool and using steam to make it spin? Then he shook his head vigorously. No, steam is so hot. If you pumped it in directly, wouldn't your hands get cooked? You gave a knowing grin and nodded. Exactly. High-temperature, high-pressure steam would definitely scald your hands. That's why I said high-pressure gas, not high-pressure steam. For example, the air we breathe, compress it with a machine, store it, and use it as power. Wouldn't that do the trick? Understanding dawned on Mu Xing, as if a new world had opened up to him. He quickly asked, then, Chief, may I ask, how is this air compressed? You understand the principle of an air pump, right? You guided him patiently. Yes. Mu Xing nodded repeatedly. An air pump is just a small bellows, the same principle as our cylinders and pistons. Before they developed steam engines, they had tinkered together little gadgets like bicycles and air pumps. How could he forget the principle? Good that you know. The air compressor I'm talking about, simply put, is using a steam engine to drive an oversized air pump. The pumped air is then channeled into a sealed steel cylinder, similar to a tire. Once the machine is running, more and more air accumulates in the cylinder and can't escape, naturally forming high-pressure air. Then, you connect a hose from the cylinder to the tool, and it provides power. Brilliant. Chief, this method is simply ingenious. Mu Xing couldn't help but slap the table in admiration upon hearing this. He wasn't deliberately flattering you. He admired you from the bottom of his heart. Not only did he admire you as a mechanical genius who could always propose wildly imaginative yet efficient mechanical principles, but he also admired your ability to use existing technology, like playing with Legos, to cobble together new inventions. Take this air compressor, for example. The steam engine was their existing mature technology. The air pump involved no high-tech elements, and the so-called steel cylinder was just a container. Yet, these technologies they had already mastered, when recombined by you in this way, transformed into something new and highly practical. This was what filled Mu Xing with profound admiration. You smiled and didn't elaborate. You couldn't very well tell your subordinate, brother, this idea isn't mine. I saw it in my previous life. Who would believe that if you said it? Arguing about it would be a pure waste of breath. All right, the air compressor project is yours. Pick your people and form an R&D team. As for the pneumatic tools, I'll give you two directions. One is using a turbine to drive gears, and the other is using a piston moving within a cylinder. Each has its advantages. You figure out the specifics. You efficiently laid out the development plan for pneumatic tools. You had no intention of just tossing out blueprints and saying, build it according to this. How would the Institute ever develop its own R&D capabilities that way? Now, they had to learn to walk on their own 2 feet. You only provided ideas and basic theories. They had to work out the specific designs themselves. If they still couldn't manage it, then all your talking these past few years would have been for nothing. Yes, Chief. As soon as we've sorted out matters at the Mint, I'll start making arrangements. Mu Xing immediately crossed his hands in acceptance of the order. The task was officially his. Good. Now, tell me about this steam locomotive of yours, you said, pointing to the blueprints on the table. Reporting to Chief, Mu Xing began, gesturing enthusiastically at the blueprints. This model is designed for mine tracks, as you specified, using a 70-centimeter narrow gauge. It has a cylindrical boiler with internal superheater tubes and fire tubes. For power, there are 2 cylinders and pistons, mounted on each side of the locomotive's front. The chassis uses a 2-to-6 two-wheel arrangement. 1 pair of leading wheels, 3 pairs of driving wheels, and 1 pair of trailing wheels. It's 3.5 meters long and can pull 15 3-meter-long cars. As for speed, according to design specifications, it can manage 40 kilometers per Shichen at full load, even uphill. Downhill, it could probably rocket to 80 kilometers per Shichen. On flat ground, it can also reach a speed of 60 kilometers per Shichen. Mu Xing gestured at the blueprints, his enthusiasm evident. The speed, especially, was calculable. The work done by the cylinder pistons per unit of time, multiplied by the circumference of the wheels, gave the most basic speed per hour. It was just that the Han tribe still used Shichen, a traditional Chinese unit of time equal to 2 hours, so converting to hours meant halving the figure. In other words, this thing could manage 20 miles per hour even fully loaded and going uphill. Downhill, due to gravitational acceleration, the speed could double. It would probably need its brakes on when actually running at that speed. Even on flat ground, it could reach 30 miles per hour. This contraption was useless for transporting bulk goods. The main reason you had them develop it was for use within the various mining areas, which would undoubtedly greatly enhance the Han tribe's mining capabilities. Furthermore, this type of narrow-gauge small train had a low load capacity, meaning the requirements for the rails weren't as stringent, making it suitable for temporary or frequently moved simple railways. For mining areas, this was a godsend. Additionally, by researching, developing, manufacturing, and using this narrow-gauge train, the Institute could accumulate experience, identify problems, and build up a technological reserve for manufacturing larger locomotives in the future. 3 birds with 1 stone. A delightful prospect. Sounds pretty good. You nodded in satisfaction. I just don't know when you'll be able to show me a physical model. Mu Xing estimated, reporting to Chief, if everything progresses smoothly, after we complete the mechanization of the Mint, we should be able to see a prototype locomotive in about half a year. He wasn't boasting. You had been pushing hard for the steam-powered conversion of the Mint, and they had been working around the clock, day and night. Currently, the Mint's conversion was basically in its final stages. Before the new year, they would be able to start manufacturing the prototype. Although the Institute had many other tasks, such as the air compressor and pneumatic tools you had just assigned, those wouldn't require many people. 1 or 2 teams would suffice. The remaining personnel could then be fully dedicated to locomotive-related R&D. The Institute's staff was growing, and soon they would no longer be troubled by a shortage of manpower. Excellent. However, there's no need to rush too much. Steady progress and safety first. Just avoid any accidents. All right, that's all I'll look at this time. I need to get to the Mint as soon as possible, so I won't disturb you here any longer. You nodded, gave a couple of instructions, and prepared to leave. Thank you for your concern, Chief. I'll see you off, Mu Xing said with a cupped hand salute, then led you and your personal guards out. Just yesterday, the Research Institute had sent several more machines to the Mint on Lake Hart Island. If you hurried, you might even catch them installing and debugging the machines by the time they arrived at the Mint. On the road, it was once again you leading a contingent of personal guards, spurring your horses onward. This time they were heading directly to Weishan Prefecture. from where they would transfer to sailboats to reach the mint on Lakehart Island. After inspecting that, if there was still time to spare, you planned to visit the Comprehensive Research Institute on Lakehart Island to inspect their work and, incidentally, assign them the task of developing rubber gloves and rubber air hoses. By the time you and your personal guards left the industrial county, the snow had stopped, but the wind was still howling. Ku Bing once again rode his horse up beside you, looking like a curious child. "Chief, that steam locomotive, is it the vehicle you mentioned before that runs on railways?" "Precisely." You held the reins with one hand and covered your mouth and nose with the other to prevent the cold wind from blowing in. A steam locomotive is a machine vehicle powered by a steam engine that runs on rails, and it needs to burn fuel to move, so it can also be called a fire car. Huoche, the Chinese word for train. Furthermore, it can pull many carriages, so it can also be called a train, liège. Call it whatever you like. Ku Bing's eyes widened at your words, and his admiration for you rose to a new level. Good heavens, how did the chief's brain work? To actually conceive of using a steam engine to power a vehicle, pulling a long string of carriages along 2 iron bars as a mode of transport. But he couldn't help asking curiously, "Chief, then why must it only run on rails? Can't the train run on ordinary dirt roads? If it has to use rails, wouldn't that limit the train's range and routes?" Indeed, any normal person would ask that. Since your steam locomotive could run on rails, why couldn't it run on roads? Believe it or not, you actually had such plans. "Of course it can run on ordinary roads," you explained patiently. "But you have to eat your meal one bite at a time. Comparatively, trains have a much larger carrying capacity, and strategically, their importance far outweighs that of road-going automobiles. That's why I need to develop trains and railways first. Only after ensuring the strategic development of the tribe can we free up resources to research the automobiles you mentioned that can run on roads." "Oh, so steam locomotives that run on roads are called automobiles," Ku Bing muttered thoughtfully, then fell into deep contemplation, saying no more. And you, following his train of thought, couldn't help but recall the history of your previous life. Steam-powered automobiles were hardly a novelty. Even in your era, where internal combustion engines were ubiquitous, steam locomotives hadn't completely exited the historical stage. In fact, the two had coexisted for a period. Speaking of World War II, that tragic global conflict was also a golden age for the explosive growth of human technology. Various black technologies of that era were invented during World War II. Of course, automobiles were not. They were already common before World War II. When it came to the most famous automobile of the World War II era, it was undoubtedly America's little Jeep. American military green Jeeps were seen all over the world at that time. But regarding trucks, one had to mention Britain's specialty back then, the Sentinel series of steam-powered trucks, a unique and outstanding industrial product in the world. Britain, true to its name as the inventor of the steam engine, truly played with steam engines in every conceivable way. The Sentinel series was the only example in the world, apart from other British companies, of successfully putting steam power onto road transport and making it a great success. The Sentinel steam truck had a long history of development. Initially, it was just a crude installation of a steam engine onto a car chassis, using solid tires, completely open-topped without even a roof. But you couldn't deny that this thing could actually run on roads. Later, the fashion-conscious British became unstoppable, stuffing all sorts of new technologies into the Sentinel. When pneumatic tires became popular worldwide, this vehicle also adopted them. However, one persistent criticism was the Sentinel's transmission system. A front-engine steam-powered truck, with the steam engine under the driver's cab and a coal furnace stuffed inside the cab, was actually chain-driven. It was even front-engine, rear-wheel drive, using chains to drive the rear wheels as the driving wheels. Bizarre, wasn't it? But no matter how bizarre, this vehicle transported a great deal of supplies for the British Army. And after final improvements, the Sentinel's chain drive was replaced with the universally adopted longitudinal drive shaft. If it weren't for its heavy pollution and the extreme hassle of starting it up, it might not have been phased out by internal combustion engine vehicles. The problem was, to get this thing running, you had to burn the furnace for an hour to light it, and wait for the steam pressure to build up before you could drive the vehicle. Just thinking about it was a pain. Even so, for the current Han tribe, it was definitely a model worth promoting vigorously. Your previously researched new national development strategy was based on the north-south waterways as the main trunk, which the Han tribe had already achieved. The next phase of transformation was to use railways to extend westward and eastward into the vast, undeveloped inland areas, using waterways as the trunk and railways as branches, gradually extending outwards, continuing to expand the Han tribe's territory, occupying, developing, and finding more human resources and other undiscovered resources. After the second phase of the strategy was completed, you might very well introduce steam trucks to promote road transport. By then, with waterways as the foundation, railways as branches, and roads as the network, the Han tribe, no, by then it should be called the Han Empire, would have its transportation system woven into a vast web. Only then could a comprehensive leap in technology and economy be achieved. Just thinking about it was exciting. The group spurred their horses, galloping towards the Weishan Prefecture docks. A journey of over 100 kilometers, they pushed on until nightfall before finally reaching their destination. Everyone was frozen stiff like popsicles, shivering, so they had to take shelter for the night at the local government office. Although it was the dead of winter, the lighthouse named Morning Star at the Weishan Prefecture docks was still lit punctually every night. Driven by a windmill, its enormous white beam of light tirelessly rotated, sweeping across hundreds of li of land and lake like a searchlight, guiding lost travelers. You and a group of personal guards, along with officials from Weishan Prefecture, sat around a hot pot in the government office building. Outside the transparent glass windows, the cold wind howled like wolves. Inside, however, it was as warm as spring, with steam rising everywhere. In the center of the room, a three-legged iron coal stove burned brightly, its long sheet iron chimney passing through a hole in the wooden wall and snaking outside. The large kettle on the stove bubbled, "Gudu-gudu," and soon the steam, pushing against the lid, let out a sharp whistle. Lu Guangzhou, who had been transferred from Xitong County to be the prefect of Weishan Prefecture for half a year, deftly picked up the kettle and brewed several large pots of hot tea for everyone. Then he added some water to the hot pot on your table before sitting down to eat with you. You picked up 2 pieces of frozen tofu, riddled with honeycomb-like ice crystals, and tossed them into the pot. While waiting for the tofu to cook, you asked Lu Guangzhou about the administration of Weishan Prefecture. "Guangzhou, how have things been in Weishan Prefecture these past 6 months? Is your work going smoothly?" Upon hearing this, Lu Guangzhou reflexively started to rise and bow. You quickly waved your hand, motioning for him to sit down and speak. They were in the middle of a meal. All this standing up and sitting down was disruptive. "Yes, reporting to Chief," Lu Guangzhou replied cautiously. "Guangzhou is dull-witted, and since being promoted to prefect of Weishan, I have found the work quite demanding. Fortunately, with the strong support of my colleagues in the government office, I have barely managed to persevere." His words were flawless. He showed humility before you, gave ample credit to his colleagues, and attributed the success to them. However, who among those who reached the position of prefect was a pushover? You couldn't underestimate him. The words of these political masters had to be carefully dissected. You never knew what hidden meaning might be lurking in a sentence. Sure enough, you immediately understood the other layer of meaning in his words. Don't forget, the dismissal and appointment of the Weishan prefect had been orchestrated by you. Why was the original prefect, Yun Jiping, transferred to Ruyang Prefecture? Wasn't it because that fellow's ambition was too great? Yunji had joined the Han tribe later, but he was immediately made a prefect. On what grounds? Because he had thumped his chest and guaranteed you he could bring in 50,000 people. He had exchanged this promise for the position of prefect. If a person could truly bring 50,000 people to the Han tribe, then his talent as a prefect was absolutely top-notch. If it were you, could you try and bring in that many? But as this fellow brought in more and more people, his ambition swelled accordingly. You had to remember, how many people did the entire Han tribe have at that time? And the newcomers in Weishan Prefecture were all introduced by him. Therefore, in the hearts of the tens of thousands of people in Weishan Prefecture, Yunji's prestige was even greater than yours, the chief. Could you tolerate such a thing? Definitely not. So, you transferred a large number of people from Weishan Prefecture to other prefectures and counties to populate the frontiers. And the result? Within 2 years, this fellow had recruited another 20,000 plus people, refilling Weishan Prefecture's population. And his personal prestige within the prefecture once again surpassed yours. Therefore, to assert your presence and also out of practical necessity, you had that godlike lighthouse built next to the Weishan Prefecture docks to let the local people know who the real boss of the Han tribe was. Then with a flick of your wrist, you issued a transfer order directly moving Yunji to Ruyang Prefecture, the very heart of the Han tribe, to serve as prefect while you yourself kept an eye on him from the neighboring Hanyang Prefecture. Without people, without power, without support, Yunji finally behaved himself. And after he left, the vacant position of Weishan Prefect was filled, according to your orders, by Lu Guangzhu, the magistrate of Xitong County. This was considered a promotion for him. Lu Guangzhu was indeed capable. Previously, Xitong County had been well managed under his administration. However, the geographical location of Xitong County was neither particularly good nor bad. Half mountainous and half plain, it lacked large water sources, so in terms of agriculture, they could only grow drought-resistant crops like wheat, corn, and soybeans. The Han tribe's main staple, rice, couldn't be grown there. Although agricultural development was limited, Xitong County's geographical location was a place of extreme strategic importance. It was roughly equidistant from Hanyang, Ruyang, Xingang, and Liuyang prefectures, a transportation hub accessible from all directions. Goods and people flowed through it endlessly, like a bustling market. Therefore, the magistrate of Xitong County, besides leading the local people to develop basic local agriculture, was also responsible for managing a large number of warehouses registering passing convoys, handling incoming and outgoing goods, and overseeing the catering and accommodation industries. The personal guards around you were all of pure Jinwu guard stock. Following you around day in and day out, it was hard for them not to come into contact with the tribe's confidential intelligence. Of course, their main responsibility was your safety. They didn't need to personally go out and risk their lives gathering intelligence. Most personal guards had no direct relationship with the intelligence department, but the secrecy regulations were ingrained in their bones. That fellow Yuji had always been responsible for the intelligence network covering Bamboo Island, the grasslands, and the Tang tribe in the southern system. As for these few prefectures right under the Han tribe's nose, the intelligence work was actually handled entirely by your captain of the guards. Therefore, when you asked him for that list of in-laws, the fellow's efficiency was astonishingly high. He produced a roster of Yunji's in-laws for you that very night. Everyone holding a position in Weishan Prefecture's industrial departments who was related to Yunji's family. Not a single one escaped. All were on the list. Early the next morning, taking advantage of the time before departure, you signed a transfer order with a flourish of your pen. It commanded everyone on the list and their families to relocate to Tuohai Prefecture within a set time limit to support the construction of various industries in the south. By the time Lu Guangzhu received this transfer order with a beaming smile, you had already boarded the ship bound for the Lake Heart Island Mint with your personal guards, leaving behind a legacy of accomplishment without seeking fame. The twin-masted, flat-bottomed river sailboat creaked and groaned as it broke through the floating ice and accumulated snow on the lake's surface, riding the wind and waves, heading straight for the Mint. After several years of diligent development by the Han tribe, this once desolate wetland, a mixture of swamps and lakes, had long since taken on a new look. Many fences made of bamboo poles had been erected in the lake, dividing the waters like a maze. On some land areas, tall, spire-shaped stone markers had been built, standing out conspicuously against the vast white snowscape. The entire wetland had been meticulously divided into multiple zones, areas where fishing and hunting were permitted, areas for raising waterfowl, busy shipping channels, and restricted nature reserves, all clearly demarcated by fences and spires. Therefore, even though it was covered by thick white snow and ice, your sailboat could still accurately follow the markers to find the mint hidden deep within. The group spent a full 3 hours reaching the mint's docks. As soon as they disembarked, they saw several other cargo ships from Weishan Prefecture moored at the docks. These ships were here to transport copper, as well as some silver and lead ore, to the mint. The mint usually had its own metallurgical department and could smelt copper, silver, and lead ingots itself. It was just that a large batch of bronze artifacts had recently been exchanged from Bamboo Island and sent to Xinjiang Prefecture for melting and reprocessing. By the time it reached the mint, it was already high-purity copper. Here at the mint, the copper would be smelted and alloyed again, adding 5% lead to optimize the fluidity of the molten copper. Only the leaded bronze produced from this ratio could allow the machines to press clearer and more delicate patterns and designs onto the coins. However, there were clearly 2 ships at the dock that were not for transporting ore, but were flat-decked cargo ships. Presumably, these were the cargo ships Lu Guangzhu had mentioned earlier, used to transport new machinery. The sailboat slowly approached the dock, and you led your retinue of personal guards ashore. First, you cordially greeted the Jinwu Guard soldiers stationed here, asking after their well-being and offering some spiritual nourishment, before leading the group in a grand procession to the mint, which was billowing thick black smoke. Of course, it wasn't on fire. It was the steam engines inside working diligently. The person in charge of the mint, having been informed in advance of the chief's impending inspection, had been waiting at the entrance early on, ready to give you a detailed account of the mint's glorious achievements. This man's name was Che Quan. He had no prominent clan background, nor any deep-rooted connections, but he was one of the earliest savages to join the Han tribe. He had learned carpentry in the Han tribe, and his name was also given to him after arriving. Later, he joined the Jinwu Guard, and because he had been a carpenter and understood some mechanical principles, he was appointed as the person in charge here. He could be considered a model of a grassroots success story. Hearing that you had arrived, this fellow hurried out from the workshop, his hands covered in black soot, not even bothering to wipe them, and cupped his hands in a salute towards you. Che Quan pays his respects to the chief. No need for formalities. You smiled and made a gesture as if to help him up, eyeing his blackened hands. Seeing your hands all greasy and sooty, are you in the middle of working? Saying this, you took the lead and walked towards the mint workshop with the others. Che Quan quickly followed by your side, step by step, saying, "Reporting to Chief, 3 new machines just arrived from the Research Institute yesterday, and everyone is busy installing and debugging them, which is why your subordinates' hands are in such a state." "Oh? What new machines have arrived? Are they installed yet?" you asked with great interest. Reporting to Chief, they are 2 disc-type edge-rolling machines, specifically for rolling grooves onto the sides of coins. 2 of them, dedicated to copper coins, have already completed debugging and are running full tilt. The remaining one for silver coins is still being adjusted, Che Quan continued to explain. Not bad. Prioritize the copper coins. After all, the demand for copper coins is greater. There's no rush for the silver coins, you said, already leading the way into the minting workshop. Upon entering the workshop, a wave of heat mixed with the smell of metal and coal smoke washed over them, accompanied by the clack-clack and rumble-rumble of various mechanical noises, making their ears ring. As far as the eye could see, there were cold steel machines, neatly arranged in the workshop according to an assembly line layout. Many workers, wearing thick gloves and masks, were busy operating at their respective stations. Small carts transporting raw materials and coal shuttled back and forth in the workshop, making creak-creak sounds. In front of each steam engine sat a stoker, meticulously adding water and coal, and constantly monitoring the steam engine's operating status, afraid of making the slightest mistake. However, on one side of the workshop, some equipment was still driven by those enormous and cumbersome windmills, looking somewhat out of place. Seeing this, you asked Chaequan beside you, "Give me an overview of the Mint's current situation. What's the steam power coverage rate? And what's the daily currency output?" "Yes, Chief." Chaequan cleared his throat and began to report. "Right now, the Mint is not short of raw materials. We are relatively close to the coking plant, so coke is supplied openly and sufficiently. And with the steam engine reforms from the Power Research Institute, key processes like smelting, casting, and rolling have all been converted to steam power, so raw materials are quite abundant. However, those two workshops are not here. If the Chief wishes to see them, we can go over there for a look first." "All right, let's go take a look then." You readily agreed, and under Chaequan's guidance marched imposingly towards the smelting workshop. The large group first went to the smelting workshop. Upon entering, they saw a neat row of smelting furnaces, like soldiers on parade. Among them were two small blast furnaces specifically for smelting silver and lead. The others were melting furnaces, the kind that used crucibles, with their fires burning bright red. On the other side of the workshop were several enormous scales used to accurately weigh the raw materials. When your group passed by, they happened to see workers adding lead pellets to a red-hot crucible. However, he wasn't adding them directly by hand. Instead, an iron box filled with lead pellets was hoisted above the melting furnace by a crane, and then the lead pellets were slowly slid into the crucible via a downward-sloping chute. The whole process looked both professional and safe. Chaequan opportunely began his introduction. "Chief, after the lead ore here is refined, it's cast into cylindrical rods. Then, using a steam-powered drawing device, it's drawn into thin lead wires, which are then cut into uniform lead pellets. These finished lead pellets, used as furnace charge, allow for a more uniform composition of the bronze alloy, a faster fusion speed, and naturally, the highest quality alloy. We usually put the copper ingots into the crucible first and heat them in the melting furnace until they liquefy. Then, we add the required amount of lead pellets through the charging port on the upper side of the furnace. During this process, the crucible is not removed, so no harmful lead vapor forms in the workshop. All the fumes produced during smelting are discharged through the chimney. After natural cooling outside, they are finally discharged into the swamp, absolutely ensuring no heavy metal gases are released outwards, guaranteeing environmental protection. Moreover, the stirring work during smelting is also done by a steam-powered stirrer. We've basically achieved automated smelting, saving time and effort." Well done. While listening to his introduction, you carefully observed the workers in the workshop and were very satisfied to see that everyone was wearing thick masks. However, still uneasy, you once again admonished, "Lead vapor is toxic, so even if there are no fumes emitted in the workshop, don't forget to wear masks when normally entering the workshop. This must be strictly enforced, no carelessness." "Please rest assured, Chief." Chaequan patted his chest and guaranteed, "Everyone knows lead gas is toxic. No one wants to inhale too much and become an idiot. So, everyone is very conscientious about wearing masks. Moreover, we have a workshop inspection department here, specifically responsible for safety inspections in each workshop. Anyone found entering the workshop not according to regulations will have their salary docked. No one dares to joke with their wages." That's very good. Workers need to be self-disciplined, but regulations are also very important. This must be maintained and become a regular practice." You nodded with satisfaction. "Yes, Chief, please look this way. This is our casting section." Jiwen responded and then led you to another area. "This is our sand mold processing area. We still use manual sand filling. However, the workload for this task isn't large, so manual labor is sufficient. Therefore, we haven't mechanized it, which also saves costs. What they are doing now is making the plate molds for casting. Look, inside this one mold there are 200 cavities. It can cast 200 thick copper plates at once. The cast copper plates are these leaded bronze alloy plates with a thickness of 1.5 centimeters. After casting over there, cooling and demolding, Once the copper plates are separated, it's the cleaning stage. Chief, please look. This is our pride and joy, the integrated washing and scrubbing machine. Chaekwon pointed to a running machine, looking rather pleased. Driven by an iron horsemark Wars steam engine, it can drive two machines simultaneously. It uses chain transmission and is specifically responsible for cleaning the cast copper plates. This step has already been mechanized, significantly shortening the time for our subsequent coining process. You watch this so-called washing and scrubbing machine with great interest for a while. The principle was actually very simple. A horizontal roller brush with pig bristles rolled and scrubbed both sides of the copper plates. Below it was a trough filled with soapy water. On the side there was a small water wheel linked to the roller brush, responsible for lifting the soapy water to a horizontal trough above, from which it was evenly sprinkled onto the copper plates through holes in the bottom. This allowed for simultaneous washing of both sides of the copper plates, achieving extremely high efficiency. Finally, after a rinse with clean water, the gleaming golden copper plates were clean, shining so brightly it dazzled the eyes. You nodded with satisfaction and casually asked, "At this point it can be rolled, right?" "Yes, Chief, let's go to the other rolling workshop to take a look." Chaekwon led the way and the group quickly moved to another workshop. This rolling workshop appeared somewhat cleaner, and there were only 3 machines, but each one looked exceptionally large, exuding a sense of industrial power. "Chief, all the equipment here are the latest 50-centimeter wide rolling machines sent from the Research Institute." Chaekwon pointed to one of the roaring machines and began to explain its functions. It uses multi-stage rolling technology, forming the product in one go, directly producing finished plates. The efficiency is top-notch. The first impression this rolling machine gave was very valuable, very expensive, because it was equipped with a full 12 gleaming silver steel rollers of different diameters. Driven by chains and gears, these steel rollers rotated at a uniform speed, emitting a dull roar as they continuously pressed the copper plates fed into them. The copper plates sent from the casting workshop, a full 1.5 centimeters thick, miraculously transformed into thin copper plates, 50 centimeters wide, and only 1.5 millimeters thick after being subjected to as many as 10 heavy pressings by this machine. They were then rolled up on an iron pipe, becoming the basic material for stamping coins. The entire process was smooth and seamless. Between the different steel rollers of this machine, there were many threaded rods and thick springs. By turning hand-operated steel wheels, the pressure between the various steel rollers could be adjusted, thereby precisely controlling the thickness of the finished copper plates. The worker responsible for this rolling machine constantly used a specially shaped vernier caliper to measure the thickness of different parts of the finished product, ensuring quality. Unfortunately, the Han tribe did not yet have the ability to manufacture precision micrometers. The precision of the lathes was not yet that high. However, for coins, an error of 1/10 of a millimeter was already within the acceptable range. This was also the highest precision the Han tribe could currently achieve. They had done their best. Next, the group looked at 2 other rolling machines responsible for silver and copper plates, carefully assessing their usage. Only when you learned that the current steam engines were more efficient than the previous rolling equipment, and that the quality of the finished products was also better, did you nod with satisfaction, a gratified smile appearing on your face. After watching this series of complex preparatory work, they finally arrived at the stamping workshop, which was the largest coining workshop. At the head of the coining workshop were more than a dozen stamping presses of different models, like rows of steel behemoths. The rolled sheets of metal were mounted on them, and then stamped into coin blanks of various diameters, commonly known as planchets. The Han tribe used a 3-tiered currency system. The smallest unit, the wen, was a simple round copper disc, crude but effective. The Jiao-level coins, however, were bimetallic, silver and copper, with an outer ring of silver and a copper core the size of a fingernail. These 2 pieces were then tightly pressed together by a machine, a rather complex process. The largest yuan-level coins were made of pure silver, gleaming and obviously valuable, After these planchets were stamped, they had to go through a grinding and washing process to remove the burrs produced during stamping and any dirt on the surface of the planchets. This step, too, had now been transformed from tedious manual operation to full mechanization, greatly increasing efficiency. The cleaned and dried planchets were then sent to the 3 recently delivered edge-rolling machines that Che Quan had mentioned earlier to roll beautiful patterns onto the sides of the coins. Using a circular track and a steel wheel engraved with patterns, uneven diagonal lines were pressed onto the sides of the coins, which was both aesthetically pleasing and served as an anti-counterfeiting measure. Coins lined up in neat rows, entering the track of the disc-type edge-rolling machine. When they emerged from the other side, they had already become coins with exquisite patterns on their sides, commonly known as reeded or milled edges. Finally, these edge-rolled planchets were fed into automated stamping presses. Pre-designed patterns and text were simultaneously struck onto both sides of the coin, and then the coin was truly finished and could be officially circulated. From the hoppers behind the stamping presses, a continuous crisp ding-ding-ding sound could be heard, the sound of finished coins falling one by one into wooden boxes, a delightful and joyful sound, like a bountiful harvest. Once such a box of coins was full, someone would take the box away with a small cart. Then the coins would be counted, sealed with paper, rolled into sticks, and finally packed into boxes. It looked just like what you see on television, rolls and rolls of silver dollars, heavy and filled with the aura of wealth. In fact, there wasn't much difference, as these boxes contained real silver and copper coins, the cornerstone of the Han tribe's economic development.